In this session, we'll be looking at solving these two pairs of simultaneous equations. In one of my previous videos, you would have seen how to go about solving simultaneous equations when the coefficient of either one of the variables were the same in both equations. Now let's look at this first equation. I have 3x take away 2y equals to 11 and 4x plus 2y equals 10. If I temporarily ignore my signs, I'm going to notice that the coefficients of y appear to be the same. So I see 2 in this first equation and I see 2 in this second equation. So I can use the elimination method to solve for this pair of simultaneous equation. Now you can do one of two things. You can either subtract both equations or you can add both equations. If I subtract both equations, I am going to get negative 2 plus 2. I'm going to get negative 4. If I add both equations, I'm going to get negative 2 plus 2 is 0, and that gets rid of my y. So in the first example, I need to add both equations. So I'm going to label my equations equation 1, and my second one here is equation 2. So I rewrote it on the side to do my working. I'm going to add both equations as I said, and I'm going to get 3x plus 4x is 7x, negative 2y plus 2y is 0, so there's no need to write that 0, equals to 11 plus 10 is 21. So now I have an equation with one variable. I can solve for x. If 7x equals 21, I'm going to get x is equal to 21 divided by 7, x is 3. Now that I have the solution of one of my variables, I can substitute this value into any one of my equations. So I'm going to write substitute x is equal to 3 into equation, let's go with equation 1. So I'm going to rewrite equation 1, 3x, that is take away 2y is equal to 11, 3, remember x, I got 3, so that's 3 multiplied by 3, take away 2y is equal to 11. Now I have 3 3s are 9, take away 2y is equal to 11. So now I have one variable in this equation and I'm going to solve it like any other linear equation. So it's going to be negative 2y is equal to 11, take away 9, I get negative 2y is equal to 2. Y is going to be equal to 2 divided by negative 2, and I'm going to get negative 1. And that's solving our first equation. Let's now solve for our second pair of simultaneous equations. I'm going to label my equations. So this here is equation, I can call it equation 3, and I can call this one equation 4. So let me examine my equations. I can see that I have the same coefficient in both equations. That is, if I ignore, let's ignore my signs. So I have the same coefficient in both equations, and I can either add or subtract both equations and use the elimination method to solve for this. So let's say I decide to add, just like my first equation. Let's say I decide to add. I'm going to get negative 4y plus negative 4y, and that is going to be negative 8y. That is not going to eliminate my y. So let's try subtracting. Negative 4y take away negative 4y. Those two signs are going to become add. So I'm going to write that here. Negative 4 take away negative 4. Remember, these two signs coming together is going to be negative 4 plus 4, and that is going to be equal to 0. So I need to subtract both equations, and I'm going to get 5x take away 14x is going to give me a negative number, as well as 7 take away 34 is going to give me a negative number. So if I decide to take away equation 4 from equation 3, I'm going to get negative values. And most students don't like to work in negative values. I mean, I don't like to work in negative values. So what I'm going to do, I'm going to take equation 3 from equation 4. So I'm just drawing an arrow here to show that I'm taking away equation 3 from equation 4. So I'm going to say 14x take away 5x. And that is going to be 9x. Negative 4 take away negative 4. We work that out. That is 0. There's no need to write that. And 34 take away 27. So if 9x equals 27, x is going to be equal to 3. 27 divided by 9, 3. And there we have our first unknown being worked out. So my next step is simply to substitute my value of x, which is 3, into any equation, and I'm going to take equation 3. So I'm going to rewrite equation 3 here. 5x take away 4y is equal to 7. 5 multiplied by 3 take away 4y is equal to 7. 5 by 3 is 15. Take away 4y is 7. So here you are seeing that you have a linear equation that needs to be solved. I'm going to be left with negative 4y is equal to 7. Take away 15. That's negative 8. So now to solve for y, I'm going to have to divide negative 8 by negative 4. When I divide a negative number by another negative number, I'm going to get a positive. 8 divided by 4 is 2. And there you have it. I have solved for both variables in my two pairs of simultaneous equations.